omnidirectional tank. So basically, it can move in any direction while still facing the same direction, is what an omnidirectional robot can do. I use the ESP8266 as is most of my projects, the WeMOS board. So I don't know how many people know what a H-bridge is, so I thought I would go over that real quick. Basically, you've got your, the one I use is this one pictured here, this Toshiba. But basically, you close the switches to make the current go one way through the motor or the other way through the motor. So if you close switch 1 and 4, the current will go from left to right through this thing. And if you close switch 3 and 2, then it'll go from right to left, and that'll switch directions for you. So that's how you can do easy DC motor control. This robot has 3 of those controllers on it. It has a total of 5 DC motors. I designed my own PCB for this. I've been playing with fritzing for a little while, but I recently switched to Eagle. Eagle is free for hobbyists. It's an Autodesk product, so you just have to have an Autodesk account, which is free. It's a bit more professional and faster. Fritzing, I've noticed, is kind of limited to one thread, so it can get bogged down pretty easily. Both of them output, though, to file formats that you can use for professional PCBs if you wanted to do that. And here's a list of the outputs from Eagle. You get the bottom, the top, the drill holes, a bunch of silk screen and solder mask stuff. Basically just photo pictures that the manufacturer would use to... Go ahead.
Is Eagle still limited to like 30 pins or something?
I don't know. I don't know what the...
What was the question?
Is Eagle still limited to like 30 pins? I don't remember what the limitation is currently. I think, if I remember right, it's on board size, so you can't make a board bigger than a certain dimension. Yeah?
I was curious, why not KiCad? KiCad, or however you say it.
Just haven't tried it. So.
What's GBR?
GBR is Gerber. That is the default format for making PCBs. It's basically a picture, black and white. So where the black is where it covers up, and where the white is where it leaves open for like an etchant to be used. Or like for the silk screen, they prevent the silk screen from being put on top of your pins that you're going to solder to.
So it's not programming?
You don't ever have to look inside these files. They're just what you would import into your CNC tool to cut it out, or send off to the manufacturer to have them make it for you. So I love making PCBs. I wanted to throw that in there. So from your Gerber files to making a board like is what's in this robot here, I use a software called FlatCam. It's an open source, hobbyist directed sort of software. And these are the steps that I use to go from a Gerber file to running my machine, which is just like a 3D printer, basically, with a spinning head on it instead of melting nozzle. So if anybody's interested in that. And the last thing that I wanted to cover about how this robot works is I use a format, internet protocol called UDP, which it just blasts away message after message without waiting to see if it actually got the message there in one piece. So that means that it's going to be faster for direct control. So I'm not waiting around for it to acknowledge that it received the message correctly So that means that it's getting more real-time data, even if it might be screwed up sometimes. So, and that's about all I have to cover about this. I'll hold up the robot for the video. Currently, I'm struggling to get it connected to the Wi-Fi and figure out its IP address. So, if you'll give me a minute, I will have that done. So, yay, camera.